Hi, in the previous video, we talked about some of the scientists who contributed and developed some of the theories that talk about the atomic structure. Today, we see the kind of contribution that Thomson added to their theories and their work. In the 19th century, J.J. Thomson was conducting an experiment on the cathode ray tube. But what is a cathode ray tube? The cathode ray tube is a closed glass tube with two pieces of the same metal inside. These two pieces of the same metal are connected to a source of electricity with a very high voltage. Once the circuit is completed, a ray is produced from the piece of metal that's connected to the negative pole of the electric source, the cathode. And this ray is continued to move in a straight line till the end of the tube. And because the ray was produced from the cathode pole, it was called the cathode ray. The next step of Thomson's experiment was to expose the ray to an electric field with a positive pole and a negative pole. It was observed that the ray was deflected toward the positive pole and away from the negative pole. What did Thomson learn from this part of the experiment? The cathode ray is not a light ray. It's composed of particles, and these particles carry a charge. It's a negative charge because the ray was deflected away from the negative pole and toward the positive pole. Remember, similar charges repel. In the following step to study the properties of the cathode ray, Thomson also exposed the cathode ray to a magnetic field, and the ray was also deflected. Thomson changed the pieces of metal, the poles. He used a different metal each time, and he had the same observations, which means that all elements have the same negatively charged particles. All atoms have electrons. Thomson used his observations in calculating the mass-charge ratio of the particles that form the cathode ray. Now let's summarize Thomson's conclusions. The cathode ray consists of negatively charged particles, which he called electrons. Cathode ray particles have thermal effect, and cathode ray particles are affected by both magnetic and electric field. They deflected by both these fields. And finally, Thomson reached his assumptions and constructed his model of atomic structure. The atom is the building unit of the matter. The atom is a positively charged sphere, and there are electrons embedded in the atom to make it neutral. This is how Thomson imagined the atom would look like, a solid positive sphere with electrons spread inside all over. And since the atom is electrically neutral, then the amount of positive charge must be equal to the amount of the negative charge. That's it for today. See you soon.